Yeah, good evening everyone. Good evening. Good evening all. Yeah, can we start? I think this is the place where we stopped yesterday. This is the place where we stopped yesterday. Yesterday we stopped here, right? Let me know first of all, is audio video okay? Let me know first of all, audio video okay or not? Check one time. Is audio video okay? Everyone, please let me know. Is audio video okay? Everyone try audio video okay or not? Yes or no? I am saying that good evening. Yeah. Good evening, everyone. Yeah, we can start now. We can start. Let me know before starting any problem is there. Mohit, is it okay? Yeah, perfect. Perfect then. Yeah, we can start. We can start now. So, right, this is the place where we stopped. Yesterday, this is the place where we stopped. This is the first problem which I given. This is the first problem which I given yesterday. This is the first problem. This is the second problem. This is the second problem, right? So let's try the first problem. Second problem we'll see again, right? Second problem we'll see again. Let's see the first problem. This is a homework, right? This is a homework. I'm starting now. I think everyone is ready. I'm starting. So let me write the date also. Yeah, what is the date today? I think 37/25. Yeah, today's class is just starting now. 37/25. Yeah, it is the first problem. It is the first problem of today's class. Yesterday I given the homework. Now I am going to do. Find true statements. Out of these 4 statements, which is the true statement we have to find out. So we have to find out. So let's try one by one. Let's try. What about first statement? Can you help me? What about first statement? Remember, if you assume left true, you have to prove right true. If you assume right false, you have to prove left false. If you assume right false, right, then you have to prove left also false. Let's check. If the right is false, means P false, substitute that value on the left side. Assume right is false. Okay, I assumed. So P is false. Substitute that one on the left side. So P is false. False followed by anything is false, true only. True, right? Negation true, it will become false. So no problem. If we assume right false, substitute those values on the left side. So left also became false. So A is a true statement. So right false means you are proving left also false. So F true. My only intention is I want to prove that TF not possible. So option A, TF not possible. If I done anything wrong, please check. Option A, TF not possible. If I done anything wrong, please check. So A is true. Let's check the remaining things also. You can do whatever method you like. Whichever you feel taking less time, that one you can try. Whichever you feel less time, that one you can try. Right? Please be careful. That one you can try. So now let me check here. So if you see the second one also, can you see the second one? Assume right false. So substitute that one on the left side. Remember, Q is false. If the Q is false, to make sure that end operation means what? Right? End operation means what? You only say. End means both the things are true, then only true. When you say end operation, both the things are true, then only true. So remember. So Q already false. So remember, if you take P as true, If you take P as true, anyhow, right? So if at all, if you take P as true, right? So this will become true, this will become true, but negation P becomes false. So I think true and false becomes false. Are you getting? Are you getting? If at all, right side is Q false. If you assume Q false, substitute wherever Q is there false. So false R operator P. So P, if you assume true, here true means here false. Suppose here false means here true. So if at all it is false, then it will going to be fail. So in both the cases, right false means left also false. Check yourself. Simply substitute. Simply substitute whatever right hand side is there. Substitute on the left hand side. So left also becoming false. Left also becoming false. Try to understand. So Q is false. Left hand side Q false. When you say Q false, what about P? P may be true, P may be false. If at all P true, true or false is true, true and false is false. So if you take P as true, left side is false. If you take P as false, left side is false. So P true, if you take also false left side, P is false also, left side is false. So I think a second statement also true statement. If anyone having doubt, you can check one time. Sir, I have this doubt. You ask me, I will help you. Right? Let's go to option C. Let's go to option C. P implies Q, end operator P implies Q. Right? You can check whatever manner you like. I think B and C almost similar, but in the place of the right R operator, they kept the implication operator. Right? You assume whatever way you want, left true, prove right also true, or right false, assume left right false, then prove that left also false. You go whatever way you like. No objection at all. So let's check. Anything is okay. Q false. Q false. I have to prove left also false. Let's see what will happen. So here it is false. Here it is false. Q false. So here false. Can help if it is false, let us assume P true. Let us assume that P is true. If P is true, this became false. Right? False end operation, anything, it will become false. False end operation, anything, it will become false. Right? So I already proved right false means left also false. If P is true, that is the case. Some people are asking, what about P is false, sir? If at all P false, false, which will goes to true. Right? True and false, it will become false. So I think that is also proved. C also true. If anyone not getting, so please careful. Yesterday I given the homework also. Please careful. So similar way, right? Fourth one. So right, negation P is false. So P is true. Negation P is false. Means P is true. Remember, P is true. Substitute. P is true. Okay, that is a true. P is true. So be careful, everyone. P is true. We don't know what is Q. Right? Let's try Q all possibilities. Suppose if you take Q as true, this will become true. Okay. True end. Right? It will become false. True and false becomes false. Okay. So Q as true, finally false I got. Let's take Q as false. TF. This became false and anything is false. So to this problem, answer is right. All are correct. A, B, C, D correct. Let's see all the people right what they are thinking. It is a homework. Mostly many people done. So let me check here. All are correct. Am I right or wrong? All valid. Am I right or wrong? Please let me know. All are wrong. All are right. Am I right or wrong? Check. Everyone, please let me know. All are valid. If anyone having any objection, I will check. Lack of space, I adjusted. If you want, I will delete it and I will check. Anyone having any doubt, let me know. This is also homework, I will write again. Anyone having any objection? Reddy sir, I am not okay with this problem. You say to me, I will help you. Reddy sir, I am not okay with this. You ask me, I will help you. So in my opinion, all are true statements. Mohit, is it okay? Ian, is it okay? If you have any doubt, A, B, C, D, any doubt there, I can write again. Now I have space. I can write again. Ella, are you there? Ella? Ella, are you there? Tarab, are you there? Anyone is not getting? Tarab, are you there? Ella, are you there? Mohit, are you okay? Ayan, are you okay? Check everyone. Whichever option not okay, let me know. I will explain again. Reddy sir, this option not okay. You ask me, I will help. Reddy sir, this option is not okay. You ask me, I will help. So can I go to next? Can I go to next? Can I go to next? Yes, can I move to next problem? Yeah, let's move to next. Then. Let's move to next because of no one having any problem. Let's move to next one. I'm writing the next one. Same problem I'm writing. Whatever yesterday's homework is given, I will write again. Yesterday's whatever problem is there, I will write again. So let me check once. I'm doing again. Yeah, so this problem I'm writing again. Can you see this? Yeah, this is valid or not, we have to check. I am trying. P employees are okay, and Q employees yes, and negation R or negation S. Employees negation P or negation Q. Yeah, this is the given problem. This is the yesterday's homework. Let me check. If anyone having any doubt, let me know. Let me know. So now I am giving answer. Everyone know. So if you assume left true, you have to prove right true. If you assume right false, you have to prove left also false. I am checking. Can you see this one? Assume this is false. Assume it is false. You know very well it is R operator. R operator is false. If this is false and this is also false, both are false, then only false. If you want to prove right as false, then both R operator, both should be false, then only. Remember, negation P false means P is true. Negation Q false means Q is true. Negation P false means P is true. Negation Q false means Q is right. Q is true. So conclusion, what we got? We got this. By assuming that one, we got this. This is what we got. We got this. Okay, now these values you have to substitute on the left hand side. Remember PT and QT. This is the thing which we have. But if you see left side, P is there, Q is there, R is there, S is there. Totally 4 people are there. Totally 4 people are there. Remember 4 people. I think P and Q is already fixed. Only thing which is not fixed is R and S. R and S having 4 combinations. R and S having 4 combination. P and Q having only 1 combination. P and Q having only 1 combination. Let me write now. P, Q, R, S. Understand everyone. P, Q, R, S. Remember P true. And one more. Q also true. RS we don't know all the possibilities. RS we don't know all the possibilities. What is that one? TT, TF, FT, FF. So we got this data. So left hand side, if you observe, totally 4 people are there. PQ is there, RS also there. Totally 4 people, but 2 people are already fixed. This is fixed. This is also fixed. We cannot do anything. So the only thing is R and S. So let's substitute one by one. First possibility substitute. I am substituting first possibility. If you substitute the first possibility, so P true, Q also true, R is true, S is true, S also true. Now if you observe clearly, true is true. True means true. Right? False means false. End operator. Anyone fail only. Overall become false. So first case is false came. Perfect. So if I substitute the first possibility, so total left became false. Please check. R is true, negation R is false. S is true, negation S is right, false. False are false. End operation, anyone fail only. So first possibility we tried false came. Let's go to second possibility. I will substitute second possibility. Everyone observe here. What is the second possibility? Everyone observe. Right? Let me check here. Everyone observe here. So second possibility, if you observe TF. So P and Q are T only. So this is T. This is also T. Okay. So I think second possibility TF I have to check. R is T, S is F. It is T. It is F. So R is true, negation R is false. Right? Negation that S is false, negation S is true. So true false means true. Okay. Next one. True false is false. False end operation, anything false only. Over. So this also given false. One case fail also fail only, but unfortunately no one is failed till now. Everything is perfect till now. Now third possibility. See the third possibility. P and R no change. Sorry, P and Q no change. It is a true. P and Q no change. True. But if you see the RS, FT, R is F, T, right? R is F, S is T. So this is F. This is true. This is false. Right? I think true or false is true. True or false is false. False and operation, anything false. So this is also false. So I think that is also perfect till now. Perfect. Till now perfect. Let's see the last possibility. Let's see the last possibility. Let's see the last possibility. What is the answer? P true, Q also true. Lastly, FF. I think FF. This is also F. This is also F. This is true. This is true. True and true, true. This is false. False and anything false. So using this data, I tried. Right? We got this. We got this. Right? Let's see this one. We got this. That one I substituted here. I substituted here. P true, Q true. I substituted. But RS also there. On the right hand side, RS also there. Totally 4 combination. True, 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 false, false, true, false, false. Every combination left also became false. Right, false, I assumed. I got some data. I substituted that data on the left hand side. So every time I am getting false only. So I think false, false is false implies false, which is true. So I think it is a valid statement. It is a valid statement. Let me know any objection. It's a very nice problem. It's a very nice problem. False, false is a tautology. Exactly. False, false is a tautology. Exactly. Let me know any objection. Everyone try. Let me know any objection. Ayan, do you have any objection? Mohit, do you have any objection? Tarab, do you have any objection? Ella, do you have any objection? Let me know. Let me know anyone having any objection. Is it okay? Can I move to next? Surojit, is it okay? Yeah, perfect. I think everyone saying true. Everyone saying perfect. Everyone saying perfect. Now let's move to next one. Let's move to next one. Let's move to next one. Yeah. So I think small promotion is there. Please careful this also, because it is really necessary. Otherwise, I may not say to you. Right? Let me do one time. Let me do one time. Right? So if you are really happy with the EPT classes, if you really happy with the EPT classes, you can inform to your classmates. If you really happy with the EPT classes, you can inform to your classmates. Right? In the profile section, if you go, you will find out your code. Every student having one referral code. You can refer them. You will get the 50%. Right? Referral amount you will get. You will get the 50% referral amount you will get. If you really like the EPT classes, you can inform to your classmates, your relatives, your friends, you can inform. And one more, there is a 100% job guarantee course also there. Those people who are having the career gaps, those people who are freshers, right? Those people who are freshers, those people who are having career gaps, so they can utilize this wonderful opportunity. Next one, these are our rankers. Last year and the previous year, these are the rankers. These are one of our top student, Abichal, who got the 4th rank. So some more students also there. These all are almost like last year people, right? Few more people are there also there in the previous paper. I want to see next year. I want to see next year your photo here. I want to see next year your photo here. Please try to understand. Your photo next year I want to see here. I wish your photo will be there here. Next one is going to be, right? So last batch for the GATE CSE and GATE DA 2026 is going on. Last batch, you can join the regular course, you can join the crash course, you can join the RIC course, test series or foundation course, whatever you want, you can join. It is the last batch. There is one offer is going on with 80%. 80% offer is going on. So buy one, get 3 offer is going on. If you buy this course, right, GATE regular course, combo GATE regular course, if you buy, you will get the full course also, rank improvement course also, test series also. Use this code. You will get the 80%. See, it is the best discount. 80% is the best one. My goal is not earning money. My goal is helping students as much as possible. 80% discount. No institute will give. No institute will give 80% discount we are giving. My goal is helping students as much as possible. And one more, right? Buy one, get 3 offer also going on. You can join the foundation course, which is 2 years course. You can go to the foundation course for the GATE CSE or GATE DA or both. And one more, you can go for buy one, get 2 also. If you buy the right rank improvement course, you will get the test series also. right? So for the GATE CSE, GATE DA, and for both also. Next one. So regular course is going on 80% discount. Only if you want only course, regular course you can go. GATE CSE or GATE DA or both. If you want right crash course, you can go for this. If you want the right RIC course, you can go for this. If you want foundation course, which is the 2 years course, only foundation course, you can go for this. Yeah. So these are our placed students, right? Amit Shukla got the Google, Kartikeya got Meta, he got the Kartikeya got a Meta also, Google also, and one more thing is Microsoft also, Pravalika. So there are many more people are there. I can say lakhs of people are there, not one or two. Many students are there who are placed in the big MNCs. You can go for the DSA system design course. You can go to the programming languages course. You can go to the full stack web development course, right? A full stack app development course and Oracle database course and so on, right? Now come to next one. Come to next one. Yeah, come to next one. Yeah, let's start. One important thing is coming. So everyone be careful. Everyone be careful. Very interesting here. See these ones. See this one is a very important one. See this one. Everyone try to understand one important story going on. One important story going on. Everyone try to understand. See this. P and P implies Q is implies Q. Is it right or wrong? Let me know. Is it valid or not? I want answer from all of you. P and P implies Q. Right? Implies Q. Is it valid or invalid? Please let me know. Please let me know. Is it valid or invalid? Try one time. Is it valid or invalid? Please let me know. Is it valid or invalid? Yeah, everyone know. If you assume left true, prove right also true. Right? Everyone know it may be valid. Let's check. Let's check everyone. Let's check everyone. Everyone remember it is true. If you assume left true, it is true means end operation. So this should also be true. This should also be true. If you want to say total left true, it's a end operation. Left also true, right also true. So P true, so right should also be true. It is a true. So definitely, if you want to say this as true, already P true, Q should be true. Q should be true. This is the final conclusion. So which is correct? So it is a valid statement. If you want, you can verify. It is a valid statement. So I assume left true. I assume left true. Right? So I think if you want, I can elaborate also. If you want, I can elaborate also. Can I see this one? P and P implies Q. It is a true. Assume it is. If you assume this one, the conclusions are right. P going to be true. P goes to Q also true. So because of P true, right? True implies Q. Right? Overall should be true. Means it should also be true. It should be true. Which is nothing but right hand side. Right hand side is true. So I proved Q as true finally. I proved Q as true finally. Now understand this. Now understand. As I mentioned to you, right? Right, whenever I started the story, I just written the same thing. Can you help, these two are same. If you want, you can verify these two are same. These two are same. What is the answer? Right, premises P. One more premises is P implies Q. Premises P, first premises is P, next premises is P implies Q. These two combinedly derives Q. First premises and second premises derives, right, conclusion Q. So some people are asking, it is a valid also. Sir, it is already valid. And there is some shortcut also. Can you see, everyone? There is a one shortcut. P and P implies Q. The shortcut is you can cancel these two. Then left out part is Q. That is the answer. That is the shortcut. P and P implies Q. Right? If you cancel the first person, both are P only. If you cancel it, so finally left out part is only Q. Right? Remember this particular property. They kept one name also for this, modus ponens. Right? Modus ponens. So that is the name for this. Right? This is the name. So just remember. I already proved also. This is already proved. Right? The short one is just cancel both the p's. Remember, it is the implication. P there, P implies Q there. P, if you cancel, left out person is only Q. This property is called as modus ponens. They kept one name also, some short name. Next time onwards, you can use it. Remember between these two premises, there is an AND operation. You know very well. See, there is an AND operation between premises, right? Premises 1, premises 2. In between, there is an AND operation. So, see, if you want, you can verify. So, both the first letters are P. Cancel it. Left out part is Q. So, that is the correct answer. So, this property is known as modus ponens. No one will ask you. For your convenience, I written the name also. Right? This is the shortcut. One way, right? One way is proving like this. Instead of proving every time, there are some things are there which are already proved. You no need to prove again and again. You can remember. P and P implies Q. P cancel. So answer is Q. This is called modus ponens. Right? Fine. Perfect. One more thing I want to say to you. Everyone listen. Everyone have to listen. See this? See, everyone, same thing. Indirectly, directly, same thing. See this one? Negation P, Q implies P. Careful, everyone. Negation P, Q implies P. So this can be written as, understand this one. This can be written as negation P, right? Everyone know Q implies P, right? Contra positive if you see. Q implies P, contra positive if you see. First to reverse and keep negation. The negation P implies negation Q. Contra positive. To this one, contra positive, this only. Then what happened is to this one, contra positive is this only, okay. Now if you observe clearly, first one you can cancel. Negation P, you can cancel. Remaining thing is negation Q. Same, almost same thing. Whatever happened, O per same thing. Another way of doing. Negation P, Q implies P. Negation P, Q implies P. Q implies P, contra positive is negation P, negation Q. Negation P, both are cancelled. Exactly like modus ponens. Another way of writing. Exactly like modus ponens. Right? Another way of writing. So negation Q. They kept some other name also, but no need to write again and again. They kept some other name, but you can remember almost same only. Another name they kept, because in indirect way like first one only. Let's see one more thing. Let's see one more interesting thing. I will do that also. You will get the more clarity. Can you see this one? P, one is P, another one, everyone observe, negation P R Q, which will goes to, everyone observe, which will goes to P Negation P R Q, right? Short name is P implies Q. Everyone know. P implies Q can be written as negation P R Q. Then both if you cancel, Q will come. This is another way. This is another way. This is another way. This is another way. Please remember all. Please remember all. It is the first one. It is the second one. Names not important. Names not important. Meanings only important. Whatever is the first one, second also same, another way. Whatever is second one, third one also same, another way. Another way. I'm thinking most probably everyone getting what is going on here. Most probably everyone is getting. Most probably everyone is getting. Please careful. Please careful everyone. Most probably everyone is getting. Please careful everyone. Please careful everyone. Right now I just want to say one by one all the people. All right, all the three I written. Now one more thing is there. All the three are there. One more thing is there. So let me try this. It is also very interesting. Let me try that also. What is that? Let's see. Next one more, fourth one. PRQ, careful. PRQ, P employees are deriving QRR. Is it right or wrong? We'll see now. PRQ, P employees are, will goes to QRR. Is it right or wrong? We'll see now. That this means, listen, this means everyone. Now let me do normal way first. PRQ is one premises. End operation. One more premises. P employees are employees. QRR. We have to prove it. We can do either left also, right also, anything is okay. So I am doing right hand side. Assume right false. Assume right false. Can you help me now? If you assume this as false, assume it is false. Assume it is false. If you assume it as false, I think this is false means R operator false means only one possibility. What is the answer? Q false, R also false. This is the information which we got. We got this. This is the information which we got. We got this. Now this one, Q false, R false. This one we have to substitute. This one we have to substitute on the left side. Let me substitute. Let me substitute here. I think if you observe clearly left side, P there, Q there, R there. But Q and R already fixed. They both are false. Only P left. Q and R is already fixed. So P having only two choices. P can be true, P can be false. Let me write now. Let me write now. So P, everyone observe, P, Q, R. So I think everyone know Q false, R false. That is okay. P may be true, P may be false. These are already false. Now substitute one by one. Now substitute one by one. From the left data, sorry, from the right, we got this data. From the right, we got this data. This one, let's substitute one by one. If I substitute the first one, P true, Q false, P true, R false. If you observe clearly, end operation, TF means false. False and anything false. So first possibility false came. Let's do second possibility. I am trying the second possibility. What is the second possibility? P false. Q already false. P false. R already false. False, false. Right? False, false, true. False or false, false. False and anything false. So finally, by assuming right false, I prove left also false. So it is a valid statement, everyone know. I given the proof also. It is a valid statement. Finally, I proved left also false. By assuming right false, I proved left also false. Okay, I already proved. Given statement is a true statement. Now understand everyone. See, understand everyone. See the shortcut, right? To prove this one, one way is like this. Can you see the shortcut? They given one name also. You can remember this. You can remember. Some people are asking, sir, how to remember? Next time onwards, please take care. How to remember? Very simple. Very simple. Listen, everyone. No, P employees are PRQ. Remember everyone. Remember everyone. In the P employees are, first one is this. In the P, so first one cancel. First one cancel. PRQ, P employees are, PP cancel. So the left out part is, if you observe, the left out part is, this is the left out part. RRQ. So everyone know this is equal to this also same. Both are same. Simply cancel first letter. Simply cancel first letter. P employees cancel. RRQ. So this is the way. I given proof also. Already I given proof. So careful. Already I given proof. The same thing I can write one more way also. Can you see this one? Same thing I can write one more way also. Everyone observe here. PR. Everyone listen. PR. Everyone observe. R goes to yes. Assume. So this can be written as R operator. R operator can be written as RRP also. Okay. Then what happened is this R, this one cancel. Left out part is SRP. Same thing I written. Whatever I written over, same thing I written. Another way I written. First one cancel. First one R cancel. Left out one is SRP. So same only. No need to write two times. This is also one more rule. They given one name also, but I didn't find out any use, so I am not saying to you. I didn't find out any use. That is the reason I am not saying to you. Right? Now see one more thing. You see this. Same model, one more thing. Careful everyone. Same model, one more thing. Just I am writing that also. Can you understand? This one? P and Q. P employees are. Remember everyone. Same. First letter cancel. Which will goes to R and Q. If you want, you can check yourself. You can prove also. P and Q. P employees are. So P cancel. Left out one is R and Q. This is the left out one. R and Q. This is the left out one. R and Q. R and Q. Worst case we can prove it. Whatever way I proved over. Worst case I can prove here also. The best thing is if you remember, you can solve the problem immediately. If you remember, you can solve the problem immediately. Try to understand. If you solve this, right? If you remember this one, you can solve this problem immediately. So I want to say one more problem. Can you see this also? P employees Q. Q employees R. Remember, it is almost like a transitive property. This one, P employee, both are employees. Remember, both are employees. P employees Q. Q employees R. These two people you can cancel. So left out is P employees R. Transitive property. It is a transitive property. Remember, both should be employees. Transitive property. Another name may be given. No one will ask the name. That is the reason even I also don't know. Who will remember unnecessary things? If not useful, I don't say. P employees Q. Q employees R. Q cancel. But remember, both are employee symbols. See this one. Q, this is cancel. P employees R. Q and Q employees both are cancelled. Then P employees R will be left out. It is a transitive property. Remember, all numbers I am giving numbers also. I am giving number 3 given. This is 4. 3 given. This is 4. This is 5. This is 6. Totally 6 things. If you remember, right, you can solve the problems immediately. If you don't remember also, no problem. Worst case, you may take 1 more minute extra time, you will solve the problem. 1 more minute extra time you will take, you will solve the problem. If you remember, you can give answer immediately. If you don't remember, worst case, right, whatever way we done, Hooper, similar way we should do. So now I will give whatever we done in the yesterday's class, right, today's class, in the previous problem, this problem. Whatever we done this, this one. Whatever we done this problem, same thing I will do using our rules, right? I will try here. Same thing I am doing using rules. Can you see one time? Same thing I am doing using rules. So let me write once again. P employees are end operation. Q employees S end operation. Negation R negation S. P employees are end operation. Q employees yes end operation. Negation R negation, right? Negation R negation yes. This one we have to prove. So using the rules whatever you know, using them. Can you try this? Can anyone try this? Can you try this one? Using our rules we have to prove. Finally we have to prove this. Using our rules, can you do this? Can you check one time? I will give the answer. Please try yourself using our rules. We have approximately 6 rules. They don't ask in the exam. Otherwise, I could have said the names. No one will ask you. Names, no one will ask. Who will bother about the name? Can you everyone try this? Using rules, can you solve this problem? If you don't remember those rules also, no problem. It will take 1 or 2 minutes extra. Without rules also you can do. Rules, if you know, you can do immediately. Can you try this? Everyone, can you try this? I'm expecting answer from all of you. Can you try this? Whatever rules you know, using that, can you try this? Yeah. So I think this can be written as, or this can also be written as, understand this one, this can also be written, negation R implies negation P. So negation R both cancel. So left out part is going to be negation P R negation S. Negation R implies negation R, both are cancel. This one, that one cancel. Check. Now, if you observe clearly this one, this can be written as negation S, negation Q. Right? So negation S, because of this R operator, you can change it. Negation S, R negation P, you can change it. So these two will be cancelled. This one and this one cancel. So the left out part is this. Negation Q, R negation P. This is the left out part. So finally came same. Finally came same. Fine. Finally came same. Yeah, you may be not getting, you may be not getting, you may be not getting because of first time you are doing. You may be not getting because you are doing first time. You are doing first time, maybe you are not getting. You are doing first time, maybe you are not getting. Right? Just to practice, right? Just to practice all these problems. Just to practice all these statements. Totally 6 statements I given. Totally 6 statements I given. So please understand. Please understand. See this one. Right? Only arrow. Here see. Here only arrow there. No other symbol. First one is only arrow. Second one also only arrow. Third one, if you observe, third one, it is also indirectly only arrow. So 1, 2, 3, only arrow symbol. 1, 2, 3, indirectly, directly, only arrow symbol. Now come to the fourth one. In the fourth one, one arrow symbol, one R symbol. In the fourth one arrow symbol, one R symbol. Then first symbol is cancelled. That is the fourth one. In the fifth one, if you observe, right, one arrow symbol, one end symbol, end symbol. If you see the sixth one, two arrow symbols. So two arrow symbols, one arrow, one end operation, one arrow and one R operator. Here only arrow. 1, 2, 3 is only arrow. See, only arrow is there. Only arrow is there. Only arrow symbol is there. Only implication. But in the fourth one, implication R operator. In the fifth one, implication end operation. In the sixth one, two implications. Two implications. So careful. Two implications. So careful. Right? Now move to the next one. You are a little bit comfortable. Move to the next one. Move to the next one. I'm thinking you are okay. I'm thinking you are okay. So what is the previous one? Negation P or negation Q. Now take next. Prove yourself valid or not. Yeah, valid or not to prove. S1 statement, prove. Valid or not to prove. See the first one. See the first one, S1. PRQ. End operation. End operation. QRR. Implication R. This is the S1 statement. So S2. You have to prove these two are valid or not. Yeah. So verify yourself. These are valid or not verify. These are valid or not verify. These two statements are valid or not verify. Yeah, I hope you tried. Can I give answer? I hope you tried. I am giving answer. Check similar way. Similar way, try whatever you know. Similar way you try. So left one, assume left one true, prove right true. That is one way. Otherwise, you can use the implication rules. Those are called implication rules. Apply implication rules. Technical word is implication rules. For this, so this one, to prove this, implication rules. These are called implication rules. Right? We are trying now. Implication rules we are trying. So let's see one by one. So don't worry about the right side. Don't worry about the right side. Don't worry about the right side. See the left side. See the left side. I think these two things, if you observe, P employees, P, both cancel. Both cancel. Check once, both cancel. So which is going to be QRR. Then this one, if you observe, QQ cancel. Which will goes to R. R. Everyone know, so R operator. If same is there, R only will come. So it is a valid statement. Same thing I done. I am not done anything new. Let's go to second. Let's go to second. Is it same? Am I given same? No. Little change I done. Little changes I done. So let's check one by one. This one, if you observe. So P and that one both cancel. Q, R. And this. So this one and this one, if you observe. So remaining is R, S. This is also valid. Both are valid. Check one time. Check one time. Simply small statements, 6 statements are there. Small statements, 6 statements are there. You have to take care. Small statements, 6 statements are there. You have to take care. Nothing is there. It is very simple. Nothing is there. It's a very simple. Nothing is there. Small statements, 6 statements are there. You have to take care. Small statements, 6 statements are there. You have to take care. Small 6 statements are there. Right? Try to understand. Right? I think both are valid statements. Both are valid. Now let me see your opinions. Let me see your opinion. So Ella saying that in S1, if we have P and Q, then also valid. P and Q. R and R also R only. Exactly. True. R and R also, finally R will come. Right? Finally R will come. So R and R also same thing will be there. Right? I think S1 and also R also same story. S2, I think please take care. Remember these 6 statements. Okay, perfect. I'm thinking you got it. Let me go to next problem. I think now you are perfect. Let me go to next problem. Yeah, you are correct. Ella, you are correct. Let me go to next problem. Yeah, next problem I'm trying, which may be little interesting. So let's see. It's a very interesting problem. Let's see how many people will give. S1 statement. P employees, negation P. S2 statement. P employees, negation P. R operator, negation P. Employees P. So S1, S2, 2 statements are given. Okay, now he is asking Two statements S1, S2 are given. Now he is asking, out of these two, identify yourself. Which are tautology? Identify yourself. Which are tautology? Which are contradiction? Which are contingency? Which are satisfiable? Yeah, go ahead. Which are tautology? Which are contradiction? Which are contingency? Which are satisfiable? Just understanding purpose. Just understanding purpose. Can you try this? Can you try this? Remember everyone. Can you apply above methods? Can you apply above methods? Remember validity. Can you apply for above? Can you apply above story? No. This is entirely different. This is entirely different. Can you help me now? Can you help me now? Can I apply above story for a tautology? Can you apply for this problem? Can you apply for this problem for tautology only? Only for a tautology can I apply previous story? Only for a tautology can I apply above story? Yes. So some people are asking, sir, how to do this? Very simple. Draw the table. Draw the table. Very simple. Draw the table. S1 purpose, draw the table. S2 purpose, draw the table. Truth table. Instead of thinking that much, draw the truth table. Instead of thinking that much, draw the truth table. Go ahead, draw the truth table. So if you observe P here, negation P here, P implies negation P. Right? Afterwards, negation P implies P. Assume it is 1, assume it is 2. It is 1 or 2. Draw the table, nothing is there here. Only 2 rows will be there. Only 2 rows will be there. True, false. True, false. Negation is false, true. Now P implies negation P. It is a false. It is a true. Right. Negation P implies, right? Negation P implies P. I think it is going to be right. I think negation P, which is going to be true here, which is going to be false here. Now 1 or 2. Can you see, is it tautology? Finally, remember, it is a tautology. It is a tautology. It is not a tautology. So S1 is not a tautology, but S2 is a tautology. It is a S2. It is a S1. Tautology. S2 is tautology. Okay, fine. So right, 1 is completed. S1 is not tautology. S2 is a tautology. Some people are asking, what about contradiction? Is S1 is a contradiction? No. Is S2 is a contradiction? No. So no one is contradiction. Contradiction means all false. All false. No. All false. No. So no one is contradiction. Contingency. What is the meaning of contingency? Neither tautology nor contradiction. Neither tautology nor contradiction. So what is the answer? S1 is neither tautology nor contradiction, but S2 is a tautology. So no. What is the satisfiable? At least one true. At least one true. Here at least one true there. Here also at least one true there. S1, S2. Fine. Is it okay? Fine. Yes. Can we move next? Can we move next? Can we move next? Right. Right. All tautologies are satisfiable. Yes. Right. But reverse is not true. All tautologies are satisfiable. All tautologies, right? All tautologies are satisfiable, but reverse is not true. That is okay. Right. And one more thing is, I think we are already given. Ella, we are already given the some conclusions also. Yeah, you please go through it. We are already given conclusions also. We already given conclusions also. Now one more nice problem is coming. One more nice problem is coming. Can you handle that problem or not? Check. One more nice problem is coming. Can you people handle that problem or not? Let's check. Let's check. I'm giving the another problem. Can you handle or not? Check. See this. One more problem. It is an interesting problem. It is an interesting problem. It is an interesting problem. So let me check. S1. S1. If iron is known to be corrupt, if iron is known to be corrupt, if iron is known to be corrupt, then he will not win. Then he will not win. That is the S1. If iron is known to be corrupt, then he will not win. Then he will not win. So please be careful. Next one, S2. S2. If let's see this. Yeah, fine. Hello, someone is saying hello. Hi, Metto. Hi, Metto. His name is Metto. I don't know. Hi, Metto. So what should I do? Say, if Ella is kind, if Ella is kind, if Ella is kind, then she will win. Then she will win. Just wait, just wait. One minute, 1 minute, 1 minute. 1 minute. Just 1 minute. Just 1 minute. It is a S3. It is a S3. S3 I am writing lack of space. I am writing S3 here. Lack of space I am writing S3 here. Yeah, perfect. So this is the conclusion. From S1, S2, will you get S3, which is the conclusion? Is it right or wrong? Check. Yeah, now perfect. Now you can go ahead. Now you can go ahead. From the S1, S2, will you get S3 or not? Verify. Will you get S3 or not? Verify. If iron is known to be corrupt, then he will not win. If Ella is kind, then she will win. If iron is corrupt, then he is not kind. So these are the statements. From S1, S2, will you get S3 or not? Verify. From S1, S2, will you get S3 or not? Verify. This is the tricky problem. This is the tricky problem. This is the tricky problem. Let's see how many people will give answer. Let's see how many people will give answer. Let's see how many people can handle this. Very less people can do this. Very less people can do this. Very less people can do this. Let's check. If iron is known to be corrupt, then he will not win. If Ella is kind, then she will win. If iron is corrupt, then he is not kind. So let's see how many people can handle this. Everyone try this. Everyone try this. Everyone should try this. Let's see how many people will give answer. Okay, I think I given enough time. So let me give answer. Everyone, let me give answer. I given enough time to you, so let me give answer. So you always remember names are not important. Names are not important here. Always remember property. See the property. If ion is known to be corrupt, then he will not win. See this one. See everyone. If ion is corrupt, so something like C. Then means implication. Then he will not win. Remember, he will win is W. Not win means negation W. So this is finally C implication negation W. If you have objection, let me know. Your name's not important. If corrupt, then he will not win. If corrupt, then he will not win. Corrupt, then he will not win. That's it. Your names doesn't matter. That is the reason I selected whatever name I like. I seen the iron typing, so I written iron. I seen Ella is typing, so I written Ella. Because your name's not important. If someone is a corrupt, then he will not win. Corrupt employees not win. Win is W, not win is negation W. In the similar way, see this one. If Ella is kind, then she will win, right? I think kind. Kind means K. Then she will win. Win means W. This will goes to K employees W. K employees W. K employees W. So S1 is this. This is S1. This is S2. This is S1. This is S2. S1, S2. Check everyone. S1, S2. Now see the conclusion also. We will see afterwards. S1, S2 we will see afterwards. Can you see the S3? Can you see S3? If ion is corrupt, then he will not kind. He is not kind. Kind means K. Not kind means negation K. So this will goes to C employees negation K. Now if you observe all of them, can you see this one? Can you see this one? Everyone listen. S1, S2, S3. See the S1. What is the S1? C implies negation W. What is the S2? K implies W. What is the S3? C implies negation K. Now, if you observe clearly, this can also be written as negation W, negation K. K implies W can be written as negation W, negation K, contrapositive. So using transitive property, you can cancel this. So then it will goes to C employees negation K, which is same. Using implication rules, I proved that premises deriving conclusion. Using the implication rules, I proved that premises deriving conclusion. So please check. Using transitive property, these two are cancelled. Right? First premises, last part. Second premises, first part, both are equal. Cancel it. Transitive property. Remember, both should be implication. In the S1 also implication, S2 also implication. If we want to apply transitive property, both should be implications. Right, first premises, second part, second premises, first part should be same, and both are implication. Then only you can cancel it. It will goes to C employees negation K, which is going to be conclusion. Which is going to be conclusion. Let me know any objection here. Let me know any objection. It is one of the nice problem. I given enough time also. I given enough time also. I given enough time also. Let's check. I given enough time also. Let's check. Yeah, S1, S2 deriving S3 is valid. S1, S2 deriving. Some people are asking, sir, what is the meaning? I will write the implication terminology. See this one? I will write the implication terminology. This can be written like this one. S1 and S2 implies S3 is valid. It is a valid statement. Is valid. S1 and S2 implication S3 is valid. Fine. From S1, S2 we got S3 or not? Yes, you got. It's a very nice problem. It's a very nice problem. If IN is corrupt, then he is not kind. If Ella is kind, then she will win. It's a nice problem. Remember names not important here. Remember names not important here. Can we go next? Can we go next? Bro, can we go next? Can we go next? Yeah, I think perfect. In the next class, we will see the remaining. So remember, two more classes are there. Two more classes on the YouTube. Totally 7 classes. Totally 7 classes on the YouTube. Right? Tomorrow, day after tomorrow also on the YouTube. Right? Please go through it. Almost. Logic chapter is almost over. Logic chapter is almost over. Almost over. In 2 more classes. In 2 more classes, total logic will be over. Total 7 classes. Total 7 classes. In the tomorrow's class, we will see the remaining part. In the tomorrow's class, we will see the remaining part. Right? Total logic. So I think 2 more classes are there. If you can complete that also, total logic is over. Right? We really done nice work. We really done nice work. We really done nice work. If anyone not joined in, if anyone is not joined, 80% discount going on. 80% discount going on without waiting. Without waiting. So my suggestion is EPT 595. Yeah, you can use this code. You will get the discount. You can join. Don't waste little more time. Don't waste little more time. You can go to exampreptool.com. You can join whatever course you want. If you have doubt, you can WhatsApp me. In tomorrow's class, we will see first order logic. In tomorrow's class, we will see first order logic. We will see first order logic. Now, whatever is going on is a propositional logic. In tomorrow's class, we will see first order logic. Right? Fine. Thanks everyone. Thank you so much. Thank you. See you in the next class. See you in the next class. Chalo. Thanks everyone. Bye. Good night. Good night.